So let us see few questions and answers in software engineering. Define software engineering. What is software engineering? According to IEEE, software engineering is the application of systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of the software. See, in this definition, we are applying the engineering version as we apply in civil engineering or mechanical engineering to software. So you have to tell that software engineering is the application of, because every engineering approach is systematic, is disciplined, and that has to be quantifiable. So it is an application of systematic, disciplined, and quantifiable approach. Now in software process, what happens? There is a development process, there is operation, there is maintenance. So we are applying the systematic, disciplined, and quantifiable approach for the development, operation, and maintenance of the software. What are the categories of softwares? We have various categories of software, in the nutshell, or the majority of which are system software, application software, embedded software, web applications, AI, artificial intelligence software, and scientific software. Define testing. Now, testing is a process of executing a program with the intent of finding an error. So, testing is done with an intent to find an error. Some people would argue that testing is failing or is subjected to fail if no error is found out, right? So testing is done with an intent to find an error. And when can you do testing? Testing is actually applied on the code. Many books have said that testing should start from the inception phase, means from the start of the software, from the requirement phase. That is actually not testing. Testing is with code only. That is verification, a part of conceptual level or behavior level talk at that time that okay, requirements are right or wrong, or if they are being followed or not, or design requirements has been catered in design also. But as far as testing is concerned, please be assured that testing starts when the code is there, right? What is white box testing? Now, white box, you can see through it. So white box testing does that exactly. This is a test case design method. White box testing is a test case design method that uses the control structure of the procedural design to derive the test cases. So otherwise, it is also called as structural testing. So if you are asked what is structural testing, what is the difference between structural testing and white box testing, don't be confused, because white box testing and structural testing, they are both same. White box testing is done with an intent and with an attitude to find and to go inside the program and see all the control structure, visit each and every part at least once. So you have to have a programming knowledge for that. What is black box testing? Again, black box testing, black box, can you see out of it? Can you see through it? No, you cannot see it. So black box testing is again a test case design method. No, this is very important. You have to say that it is a test case design method. What is testing? Black box testing is a testing using some black box technique. No, it is a test case design method that focuses on the functional requirements of the software, because you are not aware what is inside. You don't want to go inside. You just want to put the inputs and you want the outputs. What requirements are, if it is fulfilling, it is okay. So black box testers should not, or they may not be having, or they should not know what is inside. They might not have that knowledge or don't need to have that knowledge, but the requirements are fulfilled or not, and those requirements which are functional requirements of the software, this is functional testing. So if you are asked what is functional testing, what is the difference between functional testing and black box testing, you have to say, sir, functional testing is black box testing. It's a test case design method which focuses on the functional requirement of the software. What is verification and validation? Now, these two terms are often very confusing, and this is the first question you will be asked. Verification refers to the set of activities that software correctly implements a specific function. okay, what software is doing, whether the design is being properly implemented, whether what software is, if it is doing the right thing. Okay, we are very good with that. Verification, you have walkthroughs, right? You have reviews. These are inspection walkthroughs and reviews. These are the method of verification, right? You see, okay, you in a review you sit and you see what they are doing. Oh, that is going to function. That is right. Now, this is okay. What is validation? Validation refers to a set of activities that ensure that the software that has been built is traceable to the customer requirement, right? For verification, it may happen that the document which we can refer is a design document. But for verification, you have to go to the SRS, customer requirement, software requirement specification. So whether the product which you are making is made rightly is verification, or whether the right product has been made is validation. Means if I want milk, you have to give me milk, you cannot give me butter. This is validation. But if you're giving me, if I've asked for a butter, and if you're making milk, you make milk properly. Are you making milk properly? This is verification. What is debugging? Now, debugging is the process that results in the removal of error. Debugging means you have found out some error, and you have reported that error with some severity, and that severity, according to that bug has been removed. This is debugging. So it occurs as a consequence of successful testing, because when successful testing is concluded, the testers comes up with a report that is called bug report, and that bug report is an input for the debugger to debug, and mostly the person or the people who have implemented, they do it. Define cyclomatic complexity. Now, this is also very, very, very important question. Now, software complexity is the software metric. You have to say it is a software metric. You cannot say just software complexity is some, V is equal to E, V minus E plus 2. No, that is not acceptable. You have to say it is a software metric that provides a quantitative measure of the logical complexity of a program. You see, the term itself contains complexity. So you have what cyclomatic complexity does is a different aspect. But because it was started and it was invented to find the complexity, the byproducts are, you can say how many test case needs to be generated, right? You can say how many cycles are there, now that many numbers of test cases can be generated, and how complex the program is. Now the complexity is the important. The number, the cyclomatic complexity number says how complex your program is, and if your program is complex, you will be facing problem in design, implementation, and then in maintenance. What is error tracking? The error tracking is an activity that provides a means for assessing the status of a current project. Error tracking is not error finding. It is a means for assessing, because you are actually tracking the error only. But this is an activity which is destined, or that provides a means for assessing the status of the current project. What is the status of the current project? How you are going to assess this? You will see the error. How many errors are there? You can track error. Then you can say, oh, my status of current project is so and so. What are case tools? Case stands for, it should be in capital actually, Computer Aided Software Engineering, CASE. Now, case tools assist software engineers, managers, and practitioners in every activity associated with the software process. So they automate. So they are automatic tools. They automatic project management activities, manage all work products produced throughout the process, and assign engineers in their assist the engineers in their analysis, design, code, and test work. So they are automated tools to assist we people to actually complete, or to you say successfully complete the software engineering task in the project. What is data design? Now, data design, it transforms the information domain model created during analysis. You have done the analysis. Now you have some information domain model. Data design, what it does, it transforms this information model which has been created during analysis into the actual data structures which will be required to implement the software. Now, there is a coder, there is a person who is going to code. What he is doing is using he is only well versed with arrays. He will use array everywhere. Who is going to tell him that no, for this particular purpose you have to use linked list, for this particular tree you have to implement it through arrays or linked list. This you have to tell, that is the data design. Now, define cohesion and coupling. This is also a very, very loved question by the interviewers. Cohesion is the measure of the relative functional strength of a module. Now, the module which is doing some function, how much that function is being done by that module is the cohesion. What is coupling? Coupling is measure of the relative interdependence between among the modules. Now, there are various modules. I have some modules. Let me give you an example. This is one module, this is another module, this is third module. Now this module is for, say, showing the shape or computing the shape area. Now if it is calculating customers, say, salary, is it good? Because this is meant for only calculating the area, not for the salary. This is cohesion, this is not cohesion, means the cohesion has to be, you remove this salary computation, let it do only the shape or area computation. Now, if these two are, I'm talking about coupling now, these are two modules, this is third module. Now this is strongly dependent on this is strongly dependent on this is coupling. This has to be minimum, because if you want to change here, you have to see, oh, this is dependent on this and this. What to do? There has to be minimum coupling and maximum cohesion. This is a very good design. So what are the different types of cohesion? There are different types of cohesion like coincidental cohesion, logical cohesion, temporal cohesion, procedural cohesion, communication cohesion. What are different types of coupling? Data coupling, stamp coupling, and control coupling, external coupling, common coupling, and content coupling. So what is user interface design? UI design, as you say it. User interface design creates an effective communication medium between a human and a computer. So you have to know some standard to design a user interface. It is not just as you like or as you are pleased by some colors or some text. No, there has to be a standard which needs to be followed for user interface design. What is meant by specification? Specification, this is very important thing. These are often not being considered as an important part, but actually software is dependent on specifications only. So specification is a written document, a graphical model, a formal mathematical model, a collection of usage scenarios, a prototype, or any combination of this. Define process. This is also a very important question because the definition is very important. You may define it, I'm sure, but there has to be a precise definition. A series of steps involving activities, constraints, and resources that produces an intended output in some kind is known as the process. How spiral model works? There are various models in software development life cycles. Spiral is one of them. Spiral is an evolutionary software process. You have to say it as if you just start describing about spiral, nobody is going to listen because you have to know the basics. Spiral model is an evolutionary software process model that couples the iterative nature. So what two are combined? The iterative and waterfall. So iterative nature of prototyping, right? Prototype and waterfall are involved. So iterative nature of prototyping with the controlled and systematic aspects of the waterfall lifecycle model. So there is a combination of good things from prototype and waterfall model, and this is an evolutionary process which combines them. So it also has an emphasis on the use of risk management techniques. Now, why is spiral special? Because it has risk management also. Because knowing the risk beforehand is very good. If you do it in the maintenance phase, you are going to spend 20 times extra than what is required. What is win-win spiral model? Win-win spiral model defines a set of negotiation activities at the beginning of each pass around the spiral. The best negotiations strive for a win-win result. What is win-win result? Is you are sitting with the customer. Now he also should win and you also should win. This is win-win spiral. Mention the various views in system engineering hierarchy. The various views in system engineering hierarchy from top to bottom in order are world view, domain view, element view, and then in the later last part is the detail view. What is software requirements definition? A software requirements definition is an abstract description of the services which the system should provide and the constraint under which the system must operate. Now, if you just say that, okay, this is a description of the services with the system, which the system will provide, or these are the functions which our system is going to give, this is not complete the definition. You have to also emphasize on the constraint under which the system must operate, right? What is SDLC? This is the first question. As I said, verification, validation, cohesion, coupling, and this question. These are very important. SDLC. Now, a software cycle deals with various parts and phases from planning, testing, and deploying. So all these activities are carried out in different ways as per the needs. So each way is known as a software development life cycle. This is not a very good definition. Let me add one more thing, that software development's life cycle is a software project management technique, or right from there are various phases. In every phase, right from inception to the deployment, right? And you can add all these lines which I just mentioned. What are data acquisition systems? System that collects data from sensors for subsequent processing and analysis are termed as data acquisition system. So you have to have some sensor from that you acquire the data. The data collection process and processing processes may have different periods and deadlines. Software configuration model. Define it. Software configuration model is the art of identifying, organizing, and controlling modification to the software being built by a programming team. It is an umbrella activity that is applied throughout the software process. Very important. Now, software is, when software starts till it ends, there is a whole bunch of activities that has to go on. If I have something which I modified, I have done today, and I modified it, and I want to revisit it after, say, 2 months, how I'm going to get it, what modification I did, what bugs were reported, what bugs were removed, and what was the customer interaction in between. The art of identifying, organizing, and then controlling modifications is software configuration. What are those SCM activities? Software configuration model, because it identifies, organizes, and control modification. So SCM activities are developed to identify the change control or the change, ensure the change is being properly implemented, and report changes to others who may have interest. As I said, after 2 months, I want to visit it. Who is going to give me? This is software configuration team. What are the advantages and disadvantages of white box testing? The advantages. Software structure logic can be tested, because you are going inside, you're checking each and every aspect as far as the program is coded. Disadvantages. It doesn't ensure that the user requirements are met. Your program may be running fine, but what about the requirements? Okay. So its test may not mimic real world situations. For that we have black box testing. What is meant by loop testing? Loop testing is a white box testing technique. White box testing technique that focuses exclusively on the validity of loop testing, because in the program, in the software, you are going to use, or you are dependent hugely on this looping. So it focuses exclusively on the validity of the loop testing. So this technique can be applied in a simple loop, nested loop, concatenated loop, and unstructured loop. What is meant by smoke testing? Now, in hardware, you have a system, you just switch on, you just press the switch on button, and you see if some smoke is coming out. If the smoke is coming out, what is the point in checking it? It is always already faulty. This is hardware perspective. Let us come to the software perspective. Now, smoke testing is an integration testing approach that is commonly used when shrink-wrap software products are being developed. So what we do, we see that whether the software is testable or not. Once it is testable, because whether smoke is coming or not, if it is testable, then we go ahead. What is alpha and beta test? Alpha test is a test that is conducted at the developer side by a customer. Now there is a developer, there is a customer. Now customer comes to developer side and now the testing is done. This is alpha test. Now the customer takes the software here to his own side, or the developer deploys or code or install it. Now customer is going to check it. What is this? It's beta test. What is meant by system testing? The system testing is actually a series of different tests whose primary purpose is to fully exercise the computer-based program. So there are series of different tests. This is not only one test. There are series of different tests which is in focus, or which is primarily done to exercise complete computer-based system fully, right? To check and verify. So it verifies whether the system elements have been properly integrated and perform the allocated function. So apart from integration, this also tests, okay, function which is being provided, the task, whether it is doing it or not. This is complete function testing, so system testing. Mention the categories of debugging approaches. So there are three categories of debugging approaches. One is brute force, second is backtracking, and the other is cause elimination. Brute force, backtracking, and cause elimination. Define metric. Now, IEEE defines it as a quantitative measure of the degree to which a system component or processes possess a given attribute. So, it's a very crisp definition. You need to understand it. That a metric is actually a quantitative measure of what? Of the attribute, right? So it is a measure of degree to which these all means system component and processes, they have this attribute. This is metric. Mention some of the process models the software to be engineered, appropriate for the software to be engineered. We have linear, sequential or waterfall, prototype model, rapid development, incremental, spiral, win-win spiral, component-based development model. What is adaptive maintenance? So there are actually four types of maintenance: perfective, corrective, preventive, and adaptive. So what is this adaptive maintenance? Adaptive maintenance is the maintenance to adapt software to a different operating environment. You have made an operating system, now you are going to deploy it, because the environment is different. So you have to adapt, you have to make certain changes to adapt to that particular environment. So it involves changing the system so that it operates in a different environment from its initial implementation. What are the advantages and disadvantages of black box testing? The advantages is it simulates actual system usage, makes no system structure assumption because you are not aware of what is inside, but you are aware that I have certain requirements that the software should meet or the application should meet. But what are the disadvantages? There may be various logical errors in the software. There are errors which may become defect in later usage. So how to find it out? For that you have to go to white box testing. The possibility of redundant testing is also there in black box testing. This is a disadvantage. What are the broad categories of system requirements? Now, system requirements may be either functional or non-functional requirements. So any requirement can be functional or non-functional. So what are user requirements? User requirement should describe functional and non-functional requirement so that they are understandable by system users who don't have a detailed knowledge of technical. The knowledge shouldn't be a barrier. So you have to have in-depth or in their language description of functional and non-functional requirement so that the user can understand. So user requirements are defined using natural languages, tables, and diagrams. What is the test scenario? Test scenario is the hypothetical story to test the particular functionality of an application. So it's a hypothetical story. It serves as an input to functional testing. So what is the functional testing? Do you remember what is functional testing? This is black box testing. Structural testing or white box testing. For test scenario, we need use cases. Define an analysis model. Now, an analysis model is a set of models that serves as a technical representation of the system. So if you are asking about technical representation of the system, that will be analysis model. Define prototype. A prototype is not actual. It is just a prototype. So it's an initial version of the software system which is used to demonstrate concepts, try out design options, and generally to find out more about the problem and just possible solutions. Because you have something in hand, now you see it. When you see it, then you can say, oh, this needs some changes. Customer may say, oh, I require this, I require that. And now you can change it because you have a prototype. What is the function of the user model? The user model establishes the profile of end users of the system. Who is going to use it? Their name, their technical equipment, all those things. What is system image? System image combines the outward manifestation of the computer-based system coupled with all supporting information that describes the system syntax and semantics. This is system image. What is transform mapping? Transform mapping is a set of design steps, right? It is a set of design steps that allows a DFD with transform flow characteristic to be mapped into a specific architectural style. You have a proper DFD, right? Now, transform mapping is actually mapping. There is some transform. You can transform it and you can map it. So, you have DFD, you can transform it into an architecture style. This is transform mapping. What is traceability metric? This is also a very important question. Traceability matrix is a document in which we map the test cases with the requirement. So, mapping all test cases with the requirement is traceability matrix because you don't want to test those things which are not even given in the requirements. Every requirement should have a test case. So, there is a 101 relationship. So, in general, we check whether the application works as per requirement or whether we had covered all the required functionality through these test cases. List the metrics for specifying non-functional requirements. Non-functional requirements means which are ought to be there, like performance or security. So the possible metrics that specify non-functional requirements are speed, size, ease of use, and reliability. What is the difference between black box testing and white box testing? Black box testing, you don't have to have knowledge of internal logic of the system, which is used to develop test cases. It uses validation techniques. It is applied during later stages of testing because you need to have a code to test. The example include unit testing, integration testing, system testing, and acceptance testing. So, unit testing, integration testing, system testing, and acceptance testing, these are black box testing. White box testing. The knowledge of the internal logic of the system is used, it has to be there to develop the test cases, and it uses verification techniques, and this is performed early in the testing process. Mention the various types of maintenance. As I already suggested, there are 4 types of maintenance: corrective, adaptive, and preventive. And one more is perfective.